Hello and welcome back. Today we're going to be talking about weight. So, what is weight? Most people think of weight as in what they see on the scale. Let's say we've got a scale here and someone on top of it. They let it stabilize and eventually it says 150 pounds. Then they would say, I weigh 150 pounds, right? No, that is wrong. Throw that notion out. 150 pounds is the mass of the person, not the weight. So this is wrong, even though it's used in that way in modern English. The weight of an object is actually the gravitational force exerted on it by a gravitational field. And mass is simply a property of an object to measure inertia. So you can see these are totally different things. And by the way, you don't have to worry about gravitational fields just yet. So don't get hung up on that definition. Let's do a little thought experiment. Let's say that a 150-pound person is in the air flying because he's Superman. Actually, Superman is probably more like 300 pounds. Now, did his mass change after he left the ground? No. Mass didn't change. What about weight? Yes, weight changed as he got further from the surface of the Earth. Weight, or gravitational force, is equal to ma. Now that should look familiar, since that is literally Newton's second law. So how can we adapt this to work better with gravity? Well, if you think back to the olden days of kinematics, you'll remember that acceleration due to gravity has a letter attached to it, little g, and that stands for 9.81 meters per second squared. So if we wanted a general formula for weight on Earth, you can say weight equals mg. If you were to go through unit conversion, you'll see that the force of gravity is measured in newtons, mass in kilograms, which is exactly as we expect. Let's say we have a 50-kilogram bag of nachos. What is the weight? Well, we can find that out pretty easily from our equation that we just solved. Weight, or as it's more commonly shown as, Fg, which is force of gravity, equals mg. So Fg is equal to 50 kilograms times 9.81 meters per second squared. And if you take out your calculator, you can find that this 50-kilogram ginormous bag of nachos is 490.5 newtons of weight. This pineapple has a weight of 250 newtons. What is the mass? Well, we can use that Fg equals ma equation again, just in a different order. So Fg equals ma. We know the weight is going to be 250 newtons equals m, what we're looking for, times 9.81 meters per second squared. And if you take out your calculator and do some division, you can find that m equals 25.48 kilograms. This is a world record size pineapple. If a 200 kilogram anvil is being held by a rope by Wile E. Coyote and it's accelerating upward at 3 meters per second squared, what is the tension force in this rope? Now, that might seem like an impossible question, but let's use our gravity formula to see if we can get somewhere. Fg equals ma. So Fg for the anvil is 200 kilograms times 9.81 meters per second squared. And if you take out your calculator, you can find that Fg equals 1,962 newtons. Now let's return to Newton's second law. F net equals ma. If you remember, F net is the sum of all forces. And let's say upward is positive. So we have an upward tension force, and we have a downwards gravity force. So the sum of all forces is going to be T minus Fg equals ma. So that's T minus 1962 newtons, and mass we know, 200 kilograms, and we're given acceleration as 3 meters per second squared. So if you take out your calculator, do a little math, you find tension force to be 2,562 newtons. All right, that's all I have to say for weight. Good job and happy learning.